Okay, for what we have regarding conditional probability, we have for number 8, we're looking at the probability that the person chosen at random has a master's degree given that the person is a woman. Okay, and so we'll say in this one we have, let this M be for the master's, W for the woman, and now for what we have in the case of this conditional probability, the precondition is that the degree recipient is a woman. So for the conditional probability, okay, you're looking at out of the selected women, the probability that the woman selected has a master's degree. Okay, you're looking at taking a ratio of probabilities. Okay, that the degree recipient has a master's degree and is a woman. Okay, and this is going to be relative to the probability that the degree recipient is a woman. So for what we have in categorizing the data, okay, we have for master's degree and women, okay, we have master's, woman, you have the intersection, we have a 301, 264, okay, and this will be out of the total of the degree recipients and all. And for the women in general, we have 1,098,371. So for looking at the numbers in this particular instance, okay, we have for masters, women, we have 301,264. And again, you have out of 1,907,172, and this will be relative to the probability for the degree recipient chosen being a woman. So you have this many women out of all the degree recipients. And so with the complex fraction, which will consist of ratios with the same denominator, okay, the probability in this case that the degree recipient will have a master's, given that the degree recipient is a woman, you have 301, 264 out of 1,098,371. And if you were to express this result as a decimal, well, for what we would be looking at in this particular case would be about 0.274, about 27.4%. Now, in the case of what we have for number 9, we have a bit of a role reversal. We had the probability that the person chosen at random is a woman, given that the person has a master's degree. And so we have, in terms of layout, we have woman, precondition being the master's degree, and so we have for the intersection, we still have between the same categories, woman and masters, and we have out of the pool of those with master's degrees. So again, we have for women with a master's degree, okay, again, we're going to have 301,264. Okay. Again, out of 1,907,172. Okay. And for the probability of masters, you're looking at all the master's degrees in total. Okay, so we have 512,645. Okay, so for the probability of masters, again, you have 512,645 out of the 1,097,172. Okay, and if you were to clear away the complex fraction, okay, the denominators from the ratios will cancel. And so for the probability, okay, it's going to be at 301,264 out of 512,645. And as a decimal value, in this particular instance, Okay, this comes out to about a 0.588. Now, in the case of what we have regarding the book problem in number 10, okay, for this remaining conditional probability problem, okay, we're looking at the probability that the person chosen at random has a doctorate, okay, and the precondition is that the person chosen is a man. Okay, so we have for determining this probability, okay, this time the M is going to be for man, not masters. Okay, so we have for the probability in this one, okay, you have the probability that you have a doctorate and a man. Now the probability that the degree recipient is a man. And so for what we have in the case of having both characteristics of doctorate and man, so we have men with a doctorate, we have at 24,341, and we have for the total number of men in the survey we have 808,801. So looking at the comparisons and the numbers, okay, so we have 24,341 out of 1907172. And again, the number of men, okay, for the probability you have 808,801 out of the 1.9 million plus in all. Okay, so we have for the probability in exact terms, you are looking at the ratio of what were the numerators, and so we have 24,341 out of 808,801. Okay, and if you were to put this down as a decimal, okay, this comes out to about 3%. In fact, 0.030 or just 0.03.